Hi, I'm Ruihang, and sorry for having you all over time with me. I'll go as fast as I can. So today I'm going to present one of my POC projects, JSONFusion, which builds a columnar JSON data type on top of Apache DataFusion and Parquet. And the Parquet part is replaceable. And brief introduction of myself. I currently work at Script10DB, is an observability database. And here is my GitHub account and my email. And this POC project is in this report. Okay, before we start, let's talk about what JSON exactly we are going to handle with. JSON is only a data type, and it can be used in many different scenarios. And I start this from my work, which I usually playing with logs and metric data. So for this data, we can calculate it as it changed, but it's not changed that frequently. And we have a lot of fixed fields. So we can, this is a fundamental that we can build a columnar data format on top of it. And JSON, the data schema and the data itself may evolve. It is allowed in here. And before this project I'm talking about today, the community has a lot of previous works, which also works or enable DataFusion to work with JSON. I'm not reading it, or I'm not updated with it. So if there are others, please let me know. And at me in Script10DB, before this try, we have already implemented a JSON once, which I calculated as a bad try. It is built on top of JSONB format that it stores every single JSON row along with its format in one data point. And this is absolutely bad. Performance is not good, and its storage is also not good. Brings a lot of read amplification and write amplification. And it's hard to shut into one independent things when you only need to read a small part of it. You have to decode it row by row, and you need to read a full column of the entire JSON object. And compared with the old format, the new one do something better, at least in our workload. It stores stable paths as columns as just physical columns in arrow and Parquet. And it keeps structural while your data the structure itself can evolve without triggering a DDL. You just put your new data in and the database will sort it. So here's a quick test. I built a very straightforward SQL frontend for this POC, and it's changeable. First, I define a new data type. Actually, this is alias to string. I use a analyze rule to replace it to string. And within this type, you can define some known fields or known passes of your JSON data. Like we know every record or almost every record will have an age, will have an activity, and we know its type. By doing this, we can force the database to validate and maybe to transform your input data into the expected data type, the leaf data type. And we can insert it as a string, and then we query it. We query use dot or some other JSON operators. And to build a columnar-based JSON format, here are the three major things of this POC. So first is we want to prioritize everything possibly into the pure columnar first, and fall back to JSONB or other row format if it can't be columnized. And we want to, you can put everything dynamically into this database, into this tab, but we want to, it can be read as easy as it can. You don't need to predefine every passes like that before your data come. You can define some you have confidence with and left that's a database to infer others. And the third thing, I think it is the most important thing is after data was read into the DataFusion execution stream, where the execution actually starts, everything becomes static. The JSON is dynamic, but after it read from the storage engine, it becomes static. And I explain them one by one. First, this is obvious, and maybe let's just give it to save time. I want to mention it. By doing this, we can reuse all of existing infrastructure like index, statistics compression, and Parquet projection. Because in the Parquet perspective, it is just a struct, nothing more. There's no JSON or something. JSON only exists in the user-defined metadata, but it is a pure struct column to Parquet itself. And this is also how it presents in the memory in arrow. But also we want to do everything statically and in columnar, but the JSON itself is dynamic. So we have to process it. To do it, we classify the kind of dynamic into 4 levels, and for each level, we have different things to process with to achieve the best effort. The first, which everything is almost static, that you have some part of stable path on your data, and you can infer it, or the database can infer it very well, and they are directly stored as columns. And you may define compression, tab, or index on top of these columns. And the second is the JSON schema changes. For some data, you have this, and for another data, you have a new field. In this kind of dynamic, we resolve it by store data chunk in different files. Like for this part of Parquet file, you can have this metadata or this schema, and for that you can have another changed one. And the schema of each file are stored together, and they can be computed to a union and compatible schema over all these files involved in this query time to be a unified one. And this is not very complex. And if you have a conflict data type in one given path in one given file, we have to store it. We can't define a struct with 2 types out of box in Parquet. We can do this via some other ways, like variant data type, which is introduced last year, maybe. Or we can split the path by postfix a tab with a tab ID or different tab to make them look like different tab to the file itself. And for the last part, we have nothing. We have no idea what. For example, this is for user given data. We have no idea what user will give to you, so we can just keep it as a row-based way to do it. For example, we can store it as a JSONB for back to JSONB, or we can store it as a KV map, also in use Parquet map the tab. For this part, we assume it is harder to read. So for those four different kind of dynamic, we are actually changing or shifting our processing overhead from write time to read time. For the first, it is write once and maybe read multiple times. So we choose to pay overhead on the write time, so we only pay it once. And for our follow-up read, we can also directly read from the Parquet struct column. And for the last time, we choose not to process it as write time. we just put it into an opaque column or subcolumn and to decode it or filter it on the read time. So by doing this, we can pay exactly what we want to do to our scenario and data format and data. And to achieve real-time compatibilities, the schema part we have taught before, it can infer from stored Parquet metadata, where Parquet itself knows all schemas, except the last kind of dynamic, which is opaque. And when the query comes, we may know what files it may read based on the predicate given. And we also know the data, how the data would be used by inferring from the expression or the operators given. And by doing so, we can actually from the query without schema, without storage schema, we can tell at least for a part of the query, we can know the query itself, what kind of path it will need in which wanted data schema. But DataFusion won't allow us to do it because this is for some capability examples. This is actually very naive. For example, int and int can be an int. I want to talk about the third one. When two types of column or your two types of data conflict, for example, string and integer, you can define several different kind of compatibility rules. For example, parsing string into integer or formatting integer into string. This depends on your workload or what you expect to be, but all of them are customizable. Or you can just put a variant and let some operation on some rows to fail. Okay, and back to the planner part, DataFusion, if you are familiar with, in the very first stage of a logic plan is constructed, it requires a table schema from the table you are going to query, and DataFusion itself requires all of the columns and all of the tabs to be known and with the logic plan is building. But this can't apply to our to this JSON data type because without I/O we can't even tell if a path exists or not, or what type it is. So we have to postpone the type inference and type check to some time point later. I achieve this by first for queries like data.a or data.age. If we do nothing special, it will fall back to the built-in dot operation, and the dot operation will try to read the age as a subfield of the data column. And data column is defined as JSONFusion, and as I said, this is JSONFusion. This type is a alias of string, so you can't get a sub column of a string, and this will fail. This part is called to postpone the inference of a sub column or the data structure of your struct. And after that, we got the column. We also need to know if it can be casted or read as a expected data type, because this is also unknown at the very beginning of the planner stage, because it requires some I/O to at least read the metadata. So we resolve these two problems by do a pre-check or pre-transformation after the logic plan is built. We intercept every column access to the JSONFusion column data here to be a UDF called this get field type. It has 3 parameters. The first is a JSONFusion column, and the second is a JSON path string you want to read, and the third one is optional, which is the expected type you want to read as. And when this role start work, it first replace everything access the internal column of data to this function. So from the DataFusion perspective, from the planner perspective, it only see access to the data itself, and it can see the other JSON path accessor to the inside to the data. So this allows us to postpone the inference and check of the data structure, the inner data type, inner data schema of the given JSON column. And after the first pass, we replace everything accessed to it with this function. But when the function is constructed, the third parameter is empty, which means the data type expected is not inferenced yet. So we will do a second pass to try to inference the expected data type from query. As we know, if one thing is used in a, for example, the data.age is then later used in a function or in some operation like comparison operation, we may know its type or may not. If it's used in, for example, max, we then know max or usually accept numeric data types. So we can choose the most widest numeric data type to assign to the age. This is in the case where age is not predefined in the table definition. And if for another case, if it compared with a non-data type or non-column, for example, you wrote predicates like data.age equal to something, we then know for an equal operator, the type on both sides usually should be the same. So by reading your given query, and we can infer the expected type. We can run this path multiple times to try to resolve every unknown data access to the JSON column. So if lucky, we can given all the expected data type of all JSON access. And if after this pass, there are still some function, some get field function, the third parameter is missing, we may throw an error as, for example, the database can't infer expected time for this access. You have to write some cast operation to specify this thing. Or if it is expected, you can also throw the JSON content as a plain string, which is the default return type of this function. Because DataFusion don't actually has a wildcard type, so the function itself has to return something, and the string is a default option. And this works for queries like just select all from the JSON. You will see a plain JSON string formatted, and this is the default string output. And then we will the role in the end will fill back all inferred things to the plan, and also provide this plan to the underlying table scan plan. So the storage which behind the table scan can then check if the expected data read data type is readable, or it can be castable from based on its metadata stored. Okay, that's how it works. some internal things. And yeah, by doing that, we can achieve a pure static, or the static means everything is everything is resolved in the execution stage. And then I run a JSON bench, which is built by ClickHouse. It doesn't contain lots of query, only 5. By the way, you may see the scale of this picture is wild. It's weird. I made this by GPT, but the number is correct and the color is correct. I don't need to do some paint job myself. For code run, JSONFusion is in the third column. For code run, we can do actually, I think this is great because I hardly turn anything on top of DataFusion out of the box, and I haven't built some extra cache or something. Because the JSON bench itself only involves less than 20 columns, 20 sub-columns. So this applies perfectly to the JSONFusion's as we assume the workload it can be dynamic but almost static. So we can expect JSONFusion to perform as well as fully flattened JSON on fully flattened JSON data, which is done maybe I don't know others, but GrabCanDB on the last column doing this way. GrabCanDB run JSON bench by pre-split or pre-flatten all things into just leaf columns and store it in the database. So we can expect at least they can be even because we split all JSON data or half split them in the write process. And the result shows our expectation is correct. And this project is in a very early stage, and I only provide some high-level idea, and I left all other remaining code jobs to AI. So the code quality I can't assurance, but the idea is mine. It's from human. Okay. So if you want to read it, I suggest you to read it through another AI agent. Okay. So this is about the JSON POC. And thank you.
Well, thank you all very much for lasting for almost 2.5 hours of talks. It was great. Now we have nothing else planned. Hopefully you can stay around, finish up food, whatever, and have a chat. But thank you all very much for coming, and thank you for Databricks for hosting.